Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on pressure transient analysis using Kappa software, Kappa workstation. Especially we will use Saphir module for pressure transient analysis. And in this video, we are going to talk about well test design. All right, and it's going to be very simple. And so let's go. So here, let's click on new and recent, blank, next. Let's just say for well radius, we will have 3 inches and then pay zone 100 feet, porosity, for example, 0.3, and we will use default rock compressibility and top reservoir depth. Next. Okay, for single phase oil, and then let's say for formation volume factor B1 and viscosity 0.8. Total compressibility, this value, default value, water saturation, default value. Next, next, and simply create. All right. Okay, so designing well tests using the software is very simple. Here, let's just go to additional tools. You can see here analytical design, and we will use this. So basically, we will use analytical design for our well test design. So as usual, we will have here. By the way, this window is generate analytical design, wellbore model. For example, we will have constant wellbore storage, vertical well for our well model, reservoir model. I'm going to use homogeneous, but you can also, select dual porosity or dual permeability or composite reservoir. And then for boundary model, I'm going to use rectangular reservoir. So the dimension will be 10,000 feet in length and 2,000 feet in width. So it's going to be 10,000 times 2,000, the dimension. Okay, so for parameters, wellbore storage, for example, use default value, skin factor 0.25, and then initial reservoir pressure 5,000, transmissibility or KH, permeability thickness product, it is multiplied, or it comes from the multiplication of permeability times thickness. And let's say permeability 100 millidarcies, thickness 100 feet. So the transmissibility will be 10,000, which comes from permeability 100 multiplied by thickness 100. So the unit, of course, is millidarcy feet. And porosity 0.3. Okay, so for the boundary, distance to boundary, rectangular, we will use no flow for our 4 edges, 4 sides. All right, so we will have volumetric reservoir. And for east-west, it will be 5,000, 5,000. So the length will be 10,000. Whereas for north-south, the width will be 2,000. So distance to south will be 1,000. And distance to north is, of course, 1,000. All right, and then for total compressibility, use default value. After this, we need to input the history, test design history. It's going to be very simple. So we start with drawdown production for 200 hours with flow rate of 2,000 stock time barrel per day, followed by 20 hours of pressure buildup. The flow rate, of course, 0, followed by production again, longer period, 800 hours, but the same oil flow rate, 2,000, followed by 20 hours of buildup again, 0. Lastly, 2,000 hours, the same production rate, 2,000 stock time barrel per day. Lastly, closed by 20 hours of build-up. Very simple. Okay, and click on OK. If we generate, because we submit, because we set the production profile, which is this one, the software will calculate the pressure profile using all of this input. Okay, so let's just click on generate button. You see our production profile, and we will have the pressure profile. Very easy. And as you can see, we have pressure depletion there, which is the proof, for our closed reservoir, closed rectangular reservoir. So you have clearly pressure depletion here. Okay, and of course we have 3 buildups. Let's just say we want to analyze. We extract, start from using only one buildup. I use buildup 3, and automatically we will have the log plot. You can see this is the early time, middle time, and late time. We clearly see the, Wilbur storage. This should be the radial flow, from which we can infer the permeability, and we can infer the distance to boundary using this, late time response. You can see the effect of boundary as the derivative increases at late time. Okay, click on OK. So we have the log plot, semi-log plot, and of course the history plot. If we click on analytical, because this is the synthetic data, well test design, of course we will have perfect match. Okay, so if we click on generate, of course you will have perfect match because it's just a synthetic data rather than actual data. Okay, so you will have result here. The initial pressure exactly the same with what we input in our design. Permeability 100, skin. Okay, but now we get the the drainage area 459 acres, and PV is per volume 106 mm is million, so 106 million barrels. Okay, you can also see the log plot, and right click, result in plot like this. Okay, uncheck. I think that's all. Okay, so if you want to again design a well test, just go to analysis or additional tools, analytical design. Okay, and let's say I want to close with this. So extract, or maybe I will uncheck this show model first. Uncheck show model. Okay, uncheck show model. You don't need to do this, but it's okay. All right, and extract. I want to extract 3 buildups. Should be like this, still perfectly overlaid, because this is, idealistic design, theoretical design, right? So yeah. So we'll have the same, perfectly the same in this case, log plot, but different semi-log plot. Okay. I'm just showing, by the way. Okay, and I will use this case for our next topic, which is about estimating the average pressure. But this is the topic for another day. So I think we can call it a day. Thank you so much for watching. See you again in the next pressure transient analysis videos. Thank you.